Hello, everyone. You are all welcome to today's class. In this class, we are going to continue from where we stopped on measurement and units. So, today we are going to discuss dimension of physical quantities. Dimensions denotes the physical nature of a quantity. If you remember, in our last class, we discussed the two physical quantities we have. We have fundamental physical quantity, and we have derived physical quantity. We have derived physical quantity. We have basically 7 fundamental physical quantity, which are mass, length, time, we have temperature, we have electric current, we have amount of substance, we have luminous intensity, intensity. So these are basically the fundamental physical quantities we have. And we said derived physical quantities are gotten from the combination of 2 or more fundamental quantities, or combination of fundamental quantities and another derived physical quantities. So we have something like area, we have volume, we have velocity, acceleration, power, we have pressure, we have force, we have work done, we have energy, moment, momentum, density. All these are derived physical quantities. So today we are going to learn how to deduce the dimension of any of these quantities, be it fundamental physical quantity or derived physical quantities. So the symbols that are used to specify length, mass, and time are capital letter L for length, capital letter M for mass, and capital letter T for time. They are usually enclosed in brackets. Sometimes we can just write without enclosing it, but the appropriate things to do is to enclose it in bracket. So for dimension of length, we enclose it with capital letter L. This is dimension for length. Dimension for mass, we enclose it in a square bracket, and that of time is this. So you need to understand that for length, anything that is measured in the unit of length. What is the unit of length? Meter or centimeter. Meter or centimeter. So anything measured in the unit of length has a dimension of capital letter L. What are those quantities measured in a unit of length? Something like, start from length, we have breadth, we have height, we have distance, we have displacement. I think this is all. Length, breadth, height, distance, displacement. All of these has a dimension of a capital letter L. So, and anything measured in the unit of mass, which is kg, has a dimension of what? Capital letter M. And anything measured in the unit of time, which is second, has a dimension of capital letter T. So this is what you need to know before we move on to deducing any of these fundamental physical quantity. Let's start from number 1. Number 1 says we should deduce the dimension of velocity. To start with, what is velocity? Velocity is said to be the change in displacement with respect to time. So we said it's displacement all over time. Displacement all over time. So from what we have just stated in the previous slide, we said anything measured in the unit of length has a dimension of capital letter L. So displacement has a dimension of capital letter L. So here displacement has a dimension of capital letter L. You can put it in a square bracket. All over time has a dimension of capital letter T. This is what we have. Now, remember in mass, this I can rewrite it to be something like this, multiplied by 1 over T. And in mass, if I have 1 over x, is the same thing as x raised to power minus 1. So in that case, I will have this one to be times 1 over t is the same thing as t raised to power minus 1. So I can say the dimension of velocity is equal to L t raised to power minus 1. This is the dimension of velocity. Now, I'll give you one hint. For instance, in objective, if you're asked to deduce the dimension of capital letter T, there's no point of working it out like this. If you know the unit of velocity, you can get the dimension directly from that. For instance, we know that velocity is measured in meter per second. Meter per second. So from here, what is dimension for meter? Anything measured in meter has a dimension of L. Second, anything measured in second has a dimension of what? T. So we can quickly say that from the unit, you can get the dimension LT raised to power minus 1. Are we getting it now? Also, for instance, you have acceleration A. You know that the formula for acceleration is meter per second squared. So from here, I can get the dimension. Meter has a dimension of capital letter L, right? And second has a dimension of capital letter T. So I have LT minus 2. So these are ways you can get your dimension direct from the unit of a particular quantity. Moving on, the next one said we should deduce the dimension of force. So what is force? Force is equal to mass times acceleration. Now, here we have the dimension of mass to be capital letter M, but acceleration being a derived physical quantity, you don't have its dimension until you go and formulate it using the formula, right? So from here, we have A is equal to velocity all over time, right? Now, here, velocity also, you don't know, you don't have a particular single dimension. You need to get it from the combination of another physical quantity, which is displacement all over time. Now you have displacement to be L and time to be T, which you have to be LT minus 1. So I can now come here now for acceleration, velocity is now LT minus 1 all over T, which is capital letter T. Now, let's bring it down here. So A now is equal to this, I can write it to be LT minus 1 multiplied by 1 all over T. So we all agree that when I have 1 over T, I can rewrite it to be T raised to power minus 1. So that implies that LT minus 1 are plus open bracket minus 1. By using law of indices, we have this to be LT raised to power minus 2. Is that taken? Minus, plus times minus is minus, minus 1, minus 2. Minus 1, minus 1 gives us minus 2. Is that correct? So I have my A to be LT minus 2 as the dimension of acceleration. Now I come back to this place first. So A now is LT raised to power minus 2. So which means that the dimension of force is equal to MLT minus 2. So this is the appropriate thing to do. Some people can just write it as MLT minus 2. So the dimension of force is MLT minus 2. Now, quickly, we can also get this from what? From the unit. Remember that the SI unit of force is Newton, but the derived unit of force is gotten from what? From mass, which is kilogram, and acceleration, which is meter per second squared, which implies from what we did in the other question, we can deduce the dimension of force from this derived unit. So what is the dimension of kg, kilogram, which is the unit for mass, is capital letter M. Meter, what is dimension for meter, is L. And second, what is dimension for second, which is unit of time, is capital letter T, then minus 2. See, you can get the dimension of a particular physical quantity from the derived unit, not from the SI unit, but from the derived unit. I hope this is taken. Now, the next question said, deduce the dimension of pressure. What is pressure? Pressure is equal to force per unit area. Force per unit area. So, assuming you have not gotten the dimension of force, like what you have just done in the previous slide here, assuming you have not gotten it, you have to work it out before you substitute it into this formula to get the dimension of pressure. Now, having gotten it before, the dimension of force is MLT minus 2 all over dimension of area. Remember that area A is equal to length times breadth. So what is dimension of length? Is L. What is dimension of breadth? Is also what? L. It implies that the dimension of area is L squared. So coming back here, I have L squared. So remember, I can write it to be LT minus 2 times 1 all over L squared. So in mass, when I have 1 over x squared, it's the same thing as s raised to power minus 2. So in that case, we have MLT minus 2 multiplied by L raised to power minus 2. Now, I have L here, I have L here. L, like this, simplify that it is L raised to power 1. So I'm going to bring them together. So I have M L raised to power 1 multiplied by L raised to power minus 2 multiplied by T raised to power minus 2. By a law of indices, if I have 2 raised to power 3 times 2 raised to power 4, it is equal to 2 raised to power 3 plus 4. So in that case, I'm going to have ML raised to power 1 plus into bracket minus 2 times T raised to power minus 2. That will give us ML, that is 1 minus 2, which will give us minus 1, then T minus 2. So this implies that the dimension for pressure is equal to ML minus 1, T minus 2, T raised to power minus 2. ML raised to power minus 1, T raised to power minus 2. I hope this is understood. The next question says, deduce the dimension of power. Deduce the dimension of power. What is power? Power is equal to work done all over time taken. All over time taken. Now, what is work done? Work done is equal to force times distance. Force times distance all over time. Now, again, using the derived unit of force, which you have already gotten, right? The derived unit of force from what we got is that is MLT minus 2. This is mass times acceleration. That is linear acceleration. Then multiply by what is the dimension of distance? L. Then all over dimension of time is t. So having gotten this, here I'm going to have m L raised to power 1. Remember, this is L, it shows that it's raised to power 1. Multiply by this L, which is also raised to power 1. Then multiply by t raised to power minus 2 all over t. This is m L raised to power 1 plus 1 according to law of indices. Then t minus 2 all over t. So I'm going to have m L raised to power 2 t raised to power minus 2 times 1 over t, right? So this 1 over t becomes t raised to power minus 1. I have been doing this. So m L raised to power 2 t raised to power minus 2 times t raised to power minus 1. So now the same thing we did with L, we are going to do it with t. So I have m L raised to power 2 t raised to power minus 2 plus into bracket minus 1. So that gives us m L raised to power 2 minus 2 plus minus 1. That is going to be minus 2 minus 1, which will give us t raised to power minus 3. Minus 2 minus 1 is minus 3. I have ml square t raised to power minus 2. So the dimension of power is equal to ml square t raised to power minus 3. I hope this is understood. Okay. The next one is dimension of density. What is density? Density is equal to mass per unit volume. Mass per unit volume. So what is the dimension of mass is capital letter M, and dimension for volume, remember volume is equal to length times breadth times height, right? What is dimension for length is capital letter L. Dimension for breadth is L. Dimension for height is also L. So which means dimension for volume is L raised to power 3. So therefore, I have here to be L raised to power 3. This I can rewrite to be M times 1 all over L raised to power 3. I said in maths, 1 over x, or 1 over x raised to power 3 is written as x raised to power minus 3. So that implies I'm going to have m times L raised to power minus 3, which is equal to ml minus 3 as the dimension of what? Density. So from the unit, I can also get my dimension. For instance, the unit of density is kilogram per meter cube. So kilogram, dimension for kilogram is capital letter M. Dimension for meter is L, which is raised to power minus 3. That is ml raised to power minus 3, just like what we have here. So in case of objective, you can quickly get it. But in theory, you have to show your working how you got your dimension. I hope this is understood as well. Now, we have something like this. Remember, we said that dimension can also be used to verify the correctness of a particular formula, right? So these are the kind of questions that can come from dimension as well. The question says, the velocity v of a wave in a string depends on the tension T in the string and the mass per unit length gamma of the string. Obtain an expression for V in terms of T and gamma, which is mass per unit length, using the method of dimension. So here, solution. Here we are given velocity. Velocity V is given, right? Now, what is the dimension for velocity? We already done that. Is L T minus 1 meter per second, right? The next thing we are given is tension. We are given tension. What is tension? Tension is force in a string material, right? So the tension now is just like a force. So I can say T is equal to mass times acceleration. So what is the dimension of tension in this case? Is MLT minus 2, right? Good. The next thing is that we are given gamma, which is the mass per unit length. Gamma is mass per unit length. So it's mass per unit length. That is mass all over length. So that is going to be m L minus 1. So we have gotten the dimension for velocity, dimension for tension, and dimension for the what? The mass per unit length, which is gamma. So the question says that we should obtain an expression for V in terms of T, which is tension, and the mass per unit length using the method of dimension. So in order to solve this, remember the question said that the velocity is dependent on what? The tension and the gamma. Now, when we are writing dependency in maths, remember variation, we use what? Proportionality. That is to say that V is proportional to the tension and the gamma. This is what it implies. So in that case, to remove the constant of proportionality, we have V is equal to K is the constant of proportionality, K, T, then lambda, omega. Are we clear? So let's assume that K is unity, right? Let's assume it's equal to 1. This implies that V is equal to T omega. After getting this, you just put a subscript unknown for the T and what? And the omega. Let's put X and Y. So when you have done this, you now come and substitute the dimension of each of these parameters. What is the dimension for what? For velocity. So dimension for velocity is LT minus 1 equal to dimension for tension is MLT minus 2 or to the power of what? Of X dot, which is times. Dimension for gamma, which is mass per unit length, is ML minus 1. So I have ML minus 1 all to the power of Y. Is this clear? Now, the next thing we are going to do is to open this. Remember the power law of indices. So we are going to open this. The square, the power is going to be distributed over the whole parameters here. The same goes to this one. So the velocity we have, what do we have here? Okay, LT minus 1, let us rewrite it here. LT minus 1 is equal to MLT minus 2, MLT minus 2 all to the power of X dot ML raised to power minus 1 all to the power of Y. So now, we said we are going to distribute the power here. So we have LT minus 1 is equal to M raised to power X dot T raised to power X dot L raised to power X and T raised to power X multiplied by minus 2. That will give us minus 2X. Again, do the same with this one. I'm going to have M raised to power Y dot L raised to power minus Y. I think we don't need the bracket again since we have opened it. So we don't need the bracket again. So we have something like this. So now let's bring those that are of the same close to each other, M and M, L and L. So here we have L, T minus 1 is equal to, here is M, here is M. M raised to power X multiplied by M raised to power Y. The same goes to L. We have L raised to power X multiplied by L raised to power minus Y. Then you have T raised to power minus 2X. So the same thing, using law of indices, here is TLT minus 1 is equal to m raised to power x, because it's times, we add the power x plus y. So the same thing goes to L. You have L raised to power x, because it's times, we are going to add x plus minus y gives us x minus y. Then the next thing is t raised to power minus 2x. Now, looking at the two sides, this side and this side, so we have LT, but we have MLT here. So we are going to use law of indices to bring M to this side so that we can have equal parameters in both sides. So that here I can say M raised to power 0. Knowing really well that anything raised to power 0 is equal to 1. So it's as if I did not do anything here. So M raised to power 0, then L is 1, that's I'll give it raised to power 1, then t raised to power minus 1 equal to m x plus y L x minus y, then t raised to power minus 2x. Now I have the same parameters here, MLT, MLT. So I'm going to equate the power for m, the power for L, the power for t on the both side. So in that case, for m, I have 0 is equal to, what is the power here? Is x plus y. I can call this one equation 1. Then for L, I have what is here is 1 equal to what is here is x minus y. I can call this equation 2. And for t, I have minus 1 here. For t, I have minus 1 here equal to minus 2x. Minus 2x. So I can call this one equation 3. So having done this, the next thing is to what? Find the value of x and y. From equation 1, we have that x plus y is equal to 0, isn't it? And from equation 2, we have that x minus y is equal to 1. And from equation 3, we have that minus 2x is equal to minus 1. So from equation 3, I can make x subject to the formula. Divide both sides by what? By minus 2. So I have minus 2x equal to minus 1. Divide both sides by minus 2. Minus 2. I have minus 2 cancel minus 2, which implies that x is equal to 1 all over 2. X is 1 over 2. So I can substitute x in any of the remaining formula to get my y. Let's assume I'm using what? Equation. Any of the equation will go that has a y. Let's use equation 2. Equation 2 says that x minus y is equal to 1. So anywhere I see x, I'll put what? My value, which is half, 1 over 2 minus y is equal to 1. So in that case, I have minus y, right, is equal to 1 minus 1 over 2. I have minus y is equal to what? 1 minus 1 over 2 is 1 all over 2. Now multiply y to both sides. My y will be equal to what? Minus 1 over 2. Is this clear now? So when I now come back to my equation, which is this one, so I will now substitute the value of what? X and y. So here, v, according to the expression, is t, right? Let's look at it. T raised to power x, then gamma raised to power y. Is that clear? So v now is equal to t raised to power x. What is my x? 1 over 2. 1 over 2. Then gamma raised to power y, which is minus 1 all over 2. So I can write it finally to say that v is equal to 1 over 2, t raised to power 1 over 2 is written as what? Root t. Multiplied by gamma raised to power minus 1 over 2 is written as 1 over root t. 1 over root of what? Root of gamma. So which implies that the expression is going to be v equal to root t all over root gamma, which I can write finally to be v equal to root of t all over gamma. Is this understood? And if I like, I bring the last, that my constant of proportionality into this equation. I'll have v is equal to k root of t all over gamma. So this is my expression for velocity. This is the expression for velocity. If there's anything you don't understand, go back to the video, take your time, and watch it slowly. We are going to understand. It's very, very simple. So the last question here says, the force F acting on the wings of an aircraft moving through air of velocity v and density rho is given by the equation F equal to k v raised to power x, rho, the density raised to power y, a raised to power z. And the a is said to be the surface area of the wings of the aircraft. The question now says, use dimension analysis to determine the value of x, y, z, just like what we have just done, to determine the what? The value of x, y, z. Remember that they say k is dimensionless constant, which we can assume to be equal to 1 always. So let's get this one done also. So solution. Remember that we are told that v is velocity, just like what we have just done. Velocity, what is the dimension for velocity, which is lt minus 1. And the density is given to be rho. What is the dimension for density? Density is m l raised to power minus 3. And a is area. A is area. What is the dimension for area? Is l raised to power 3. Good. So the next thing we do now is to, now, before we move, what is the dimension for force? F is equal to mlt minus 2. Having done this, then we take our formula F equal to k vx rho y, then a raised to power z. Remember, let k equal to 1. If k is equal to 1, F is now equal to v raised to power x, rho raised to power y, a raised to power z. I hope this is taken. Then, when you are done with that, we now come and substitute the value of what? The dimension of each of these parameters. F is mlt minus 2, right? Equal to, what is v? Velocity is lt minus 1 all to the power of x. The next thing is density, rho. What is the dimension of density? Is, put dot here showing that multiplication. Dimension of density is ml minus 3 all to the power of y. And the dimension for area is, dimension for area is l raised to power 2, right? Meter square, L squared. So multiply by L raised to power 2 all to the power of what? Z. Is that clear? Then using power law of indices, we are going to have here to be, here is mlt minus 2 is equal to L raised to power x, then t raised to power minus x, right? According to the law, power law of indices. Then dot, which is multiplication, distribute the power over the whole parameters inside. Distribute the power over the whole parameters inside. I have m raised to power y, l raised to power minus 3y. Then the same thing with this is going to give us L raised to power 2z. Then after that, if you look at this side, you have L here, you have L here, you have L here. You have to bring them together so that you can use another law of indices to simplify it. So I have M L T minus 2 is equal to L raised to power x multiplied by L raised to power minus 3y multiplied by L raised to power 2z, then multiplied by T raised to power minus x multiplied by M raised to power y. Then the next thing is to use law of indices. When you're multiplying, then you add what? The powers. So now I have ML raised to power minus MLT raised to power minus 2 will now be equal to L raised to power x plus minus 3y, which will become minus 3y, then plus what? Plus 2z, right? Then what else? Multiply by t raised to power minus x multiplied by m raised to power y. So let us arrange the way it is on this side. You have MLT, here is LTM. Let us make it to be MLT as well. So I have MLT raised to power minus 2. MLT raised to power minus 2 is equal to, here I have m raised to power y, m raised to power y, multiplied by L raised to power x minus 3y plus 2z. Then what is t raised to power minus x? T raised to power minus x. Now, we are now going to compare the two sides. Now here, m is single, that is m raised to power 1. Same goes to L raised to power 1. So I'm going to have m raised to power 1 here, L raised to power 1 here, T raised to power minus 2 here, equal to m raised to power y, L raised to power x minus 3y plus 2z, right? Then multiplied by T raised to power minus x. Now, we're going to compare the power, making reference to each of the parameters here. So for m, we have 1 here. 1 is equal to, for m here, we have y. So 1 is equal to y, which implies that y is equal to 1. For L, we have 1 here on this side. 1 is equal to, what we have here is x minus 3y plus what? Plus 2z. Is that clear? And for t, we have what? We have minus 2 here is equal to minus x. So which implies here that x is equal to what? 2. Minus cancel minus, x is equal to 2. So far we have gotten the value of x. We have gotten the value of what? Y. What we need to get now is the value of z. So to get the value of z or z, as the case may be, we have from this, we have x minus 3y plus 2z, right, is equal to 1. So by substituting the value of x and y, we have x is 2 minus y, 3 into bracket. What is y? Y is 1. 1, then plus what? 2z is equal to 1. That implies I have 2 minus 3, 3 times 1, or minus 3 times 1 is minus 3, plus what? 2z is equal to 1. So now I have minus 1 plus 2z is equal to what? 1, right? So from here, I can have 2z or z equal to 1 minus 1 crossing the equality sign, change to plus. That is going to be plus 1. So which means I have 2z is equal to 2. Divide both sides by 2, then which implies that z is equal to 1. So I have the value of x is equal to 2. The value of y is equal to 1, and the value of z is equal to 1. So this is what the question says we should find. So sometimes the question might ask you to give the expression like what we did in the question 6. So in order to give the expression, we now come back to our initial formula, right? Our initial formula. So, and substitute the value of what? X, Y, Z. So our initial formula is that F is equal to K. F is equal to K. I mean this initial formula. Where is it? Yeah, initial formula here. K V raised to power X, the density raised to power Y, and the area raised to power Z. So the formula now becomes F is equal to K V squared, rho raised to power 1 is rho, then A raised to power Z, which is 1. So the formula now becomes F is equal to, the expression is going to be F is equal to K, the constant, V squared, then rho A. So this is what you get as the expression. I hope this is understood. So this is where you're going to stop in this class. So now what I will ask you to do, now is to deduce the expression for work done. Number 1, deduce expression for work done. Number 2, expression for momentum. Then expression for moment. And lastly, expression for kinetic energy. Let me give you 5 questions. So kinetic energy, the last one is expression for potential energy. So potential energy. So this is what we are going to do to test your understanding. So having done this, at least we have finished one topic on physics. So the next class, we are going to practice Jamb question using test daily lab. So thank you. We'll meet in the next class.